Welcome to Hot Topics. I received a question here the other day that was interesting from a grounding expert whom I think quite a bit of. And his question was, when was it required in the code? I kind of liked what he said there. When was it required? And what he was talking about, like this main building you see in the illustration, center building, that building may be in a substation, or it just might be in another building located on the premises, for instance. But we're running a feeder from the main building over to building 1. And his question was, could the equipment ground be routed over there and the grounding electrode system eliminated, and the equipment ground would ground everything in this facility back to the earth ground in the main building? Well, going back to the 1996 NEC 250-24A dealt with grounded systems. And exception 1 to 250-24A would allow a branch circuit routed over there, single branch circuit, and the equipment ground could ground everything in building 1 back to the main building. But the exception 2 would allow the designer installer to route an equipment ground over, as you see in building 1, and all your equipment in there would be bonded and grounded back to that bar there that would be grounded and bonded into the can. But the grounding electrode would be eliminated just as this individual asked. But notice that permission was given in the 1996 NEC 250-24A exception 2. Now, there was a big change took place in the 1999 NEC. In other words, Article 250 was rewritten, and 250-24 was renumbered and relocated to 250-32B. And you could do it either way. You could route over and use the grounded conductor as an equipment ground, a neutral, and a bonding means to bond metal enclosures from earth grounded in building 2 back to the main building. But you were looking at 250.32B, and naturally you were looking at the information that was given there. Rewritten completely, Article 250. Now, what they did next, they brought into, and if you don't mind, I'm going to move these code books out of the way, the 2002 code revised 250.32, and they said, well, now, if you wanted to, for example, in the illustration that you see here, this is our second illustration. Notice that grounded conductor pulled from the main building to building 2 is used as an equipment ground, a neutral, and a bonding conductor, and it's connected into an electrode system, as you see here, from 250.50, 250.52, and 250.53. Or you could route it from the main building to building 1 and connect it in a sub-panel configuration in accordance with 408.40, and you notice that you'd isolate that neutral. Now, you'd calculate the neutral load, you'd size the equipment ground based upon the overcurrent device in the main building for the equipment ground, connected into the earth ground, just as you see in the illustration, and you'd use the larger of the 2. For example, say, and we're just using an example, you had a 225 amp main in the main building. You route that equipment ground over to building 1, then the 225 amp main per table, 250.122 in this revised edition, would require a number 4 equipment ground. But you calculated the neutral load, 220.61, to be a 1 then it'd have to be a 1/0, see, not a number 6. You'd use the larger of the two as required in 250.32b, and it would be item number 2 there. Now, say that you calculated a number 6 neutral, very little neutral load, but a lot of 3-phase and single-phase loads without neutral connections. Then it'd have to be number 4, because the equipment ground had to be number 4, so you'd use the larger of the two, as the 2002 NEC would require you to do naturally. Now, the next thing that we would want to look at, in the exception to 250.32a, you could run a branch circuit over and use the equipment ground to ground everything in the building back to the earth ground in the main building. And of course, you know, in Article 100, a branch circuit defined could be 1 ungrounded conductor neutral, 2 ungrounded conductors in a neutral, or 3 ungrounded conductors in a neutral. And that would be considered a multi-wire circuit. But if you run a hot neutral, hot neutral, hot neutral, in other words, 3 individual ungrounded conductors, 3 individual neutral conductors, and you're not a branch circuit anymore. You would have to set a panel board, see. Now, so that's the exception that we would have there that we could use. Now let's move to the next illustration. And notice, if you were sizing the equipment ground, and you had this 225 amp main that we gave an example earlier, then notice in the step 1, the 225 amp overcurrent device requires a number 4 selected from our table 250.122. Don't get mixed up here now, because a lot of people do. They want to size the grounding electrode conductor that you see in the panel connected into the earth ground with a number 4 size from the overcurrent device, 225 amp rating. That would be wrong. It would be sized upon these number 4 conductors terminating here, and it would be a number 2 if it was connected to structural steel or a water pipe system that is considered metal, and it is also considered as an electrode from 250.52A1. Then it would have to be naturally a number 2, so selected from table 250.66. So now kind of keep that in mind. But again, the neutral that you see in the panel board in building 1 is sized from 220.61. It could be smaller than number 4, and you'd have to use number 4. Or it could be calculated by 220.61 to be larger than the number 4 equipment ground, and it might be 1/0, as we said, so you'd increase it to a 1/0 is 250.32b, I believe item 2 would naturally require us to do. Now, moving to the next illustration. It's just a little example here, maybe a little out of whack a little bit, but you notice a 225 amp main would require a number 4 for grounding, equipment grounding purposes. And if you calculated, say, a number 8 or a number 6 neutral load, then it had to be brought up to number 4. And you'd say, well, no, I calculated by 220.61 a 1/0. Then it would be brought up to a 1/0. And this is kind of what the illustration is showing. It's we're kind of making it as an example only, but the question is, what size neutral is required based on load? The load is 50 amps, so it's up to the engineer. They can naturally go to 215.2A1 and look at the exception and size it at 100% or size it at 125%. Whatever they want to do is permissible. So 50 amps, we're sizing it at 100%, so it'd be 50 amps. In the step 2, we're applying 250.32B1 exception 2 and using table 310.16, and a 50 amp load would require number 8. But however, And the Step 3 250.32B1 exception 2, along with the use of Table 250.122, a 225 amp overcurrent device, would require a number 4, so you'd have to use number 4, the larger of the number 8 or number 4. But again, if you calculated in Step 2 a larger neutral, like a 1-aught maybe, or 2-aught, whatever, it would have to be used because it's larger than number 4. And that's exactly what was required in the 2002 NEC when you review those rules in 250.32B. Now, again, a revision was made to 250.32 in the 2005 NEC. And now they were saying there that, you would have to follow the rules, and, it would almost have to be like existing for you to take a grounded neutral conductor, use it as an equipment ground, a neutral, and a grounded conductor, as well as a bonding jumper. So we would have to, go over those rules. So let's look at our next illustration. And notice we're basically just reviewing when do you need to connect it as a subpanel, as you see in Building 1, or could we use the grounded conductor as an equipment ground, neutral, and bonding jumper? You can only do that when you look at the 2005 and you look at the next edition that had revisions to this section was 2008. And then if you look at the 2011, 2014, 2017, and 2020, then it either has to be existing in those cases, or you'd have to connect it in a subpanel, and you can't have parallel paths. That's the main thing. So read, if you really want to have a little case study of this, start with the 1996 NEC and just go through each code revision up to the 2020, and you'll find the information that I'm quoting to you. And it's all based upon the type of installation and when it was made and by which particular code was enforced at the time the installation was made. Now, basically, that's when it's required, starting with those codes. So, my name is James Grace Stallcup. I thank you for watching this video. And again, folks, if you like our videos, hit that subscribe button, because we're going to bring you some good information with videos that will help you with your knowledge on different areas that design and installations, as well as maintenance and inspection, are made from the previous editions of the code as well as the latest code. That's a lot of information, but we look forward to bringing you these videos. But give us a helping hand by hitting that subscribe button, and I can tell you for sure I would surely appreciate it. Again, James Grace Stallcup, thank you for watching this video.